Here we are, Team Blue Teeth, and this is going to be our presentation for assignment 2. I'm Team Leader Matthew Beams. Our group also includes Luke Grafgaver, Benjamin Champion, Brenton Stafford, Pat Tugdog, and Thanun Zaman, but we don't entirely know what happened to him. Anyway, hope you enjoyed the presentation. The remote community of Bendy Downs relies heavily on its tourism industry. We felt the best solution wirelessly for them would be to integrate a wireless monitoring system for day and night. And in our research, we came across a lot of solutions that we could do for wireless as a project. We looked at things like automatic gates and things like that, but still we settled on the cameras, thinking that would be the most beneficial to the tourism industry. This is what our team has deemed as our most important needs. We need something that's got nice clear vision, works at night, but most of all, we're keeping costs down. Alright, from our needs and metrics, we came up with these targets. We think that, importantly, it needs to see about 20 metres at night, needs to be waterproof with those conditions in the area, would preferably have it under $500 a camera, and overall costs, try and keep it under $6,000.
After we did our targets, we came up with a concept screening process. In this one we did microwave versus wireless and satellite. In the end we came up with microwave and wireless N being the two best systems, and so we took them into further concept screening processing. Okay, in this one we took the microwave and the wireless N into more detail. We put weightings on various things which we thought were important, so like cost was our most important, and power consumption, because they have limited power resources out there. We ended up with the wireless N system winning. Okay, in this concept screening we were testing the night vision system. We ended up with the infrared system over the inbuilt night system, mainly due to the cost and power consumption. Okay, this concept screening is an inbuilt onto the last one. We obviously did the inbuilt infrared versus the infrared attachment. We ended up with the same scoring for both of them, but in the end we went with the inbuilt infrared because it's already into the cameras we want to use and it's a much more reliable system. Okay, this is the concept screening we were doing for the protective box of our camera. We ended up with Perspex as it's clearly much better than both stainless steel and wood. Okay, we again took the two highest rated ones from the previous slide into further concept screening. In this case it was Perspex and stainless steel. And as you can see, Perspex clearly won again, mainly due to the cost.
Our next part is the concept design process, and our first draft concept design is the solar camera. As you can see, the solar power is what we thought would be pairing the viewing station, the camera and the control system, which is going to move the camera, which the camera sends its signal through wireless back to the viewing station, and yeah, it's just all run off solar. Our next draft concept design is called the box protection. Now for this one we've just got a standard power source which runs to the viewing station, and the wireless signal is transferred to the camera, which is also running off a standard power source. And the control system, which is controlling the movement as well, and it's all protected within a box, like just for weather and climate and whatnot.
At this point, it becomes necessary to explain exactly what the box is. As the Bendy Downs property is in a remote outback area, the cameras will need to be shielded from physical damage and rough weather conditions. We have solved this problem by constructing a protective frame that the camera is mounted inside. A hole is cut in the front so as not to affect the image quality and infrared LEDs. As Ben showed earlier, we chose Perspex as the material for the box as it offers the best balance between cost and effectiveness and also allows for easy routine inspection of the cameras. Stainless steel probably would have offered more protection, but it's prohibitively expensive and working with the material would have been a lot harder. Now let's see how this all comes together.
Our next draft concept design is the basic camera. Now as you can see we've just got a standard power source, and the red lines represent where that power source is going to. As you can see you've got the wireless router, the viewing device, the control mechanism, rotating mechanism in the camera. And yeah, they all join in one and it moves the camera, and the wireless router transmits to the camera and also transmits to the rotating mechanism to tell it to turn as well. And yeah, that's basically the basic setup of what we're thinking. Our next draft concept design is the infrared camera. Now as again we've still got the same power source, and it's the same as the basic camera, except now we're incorporating night vision, and yeah, it's just all running the same as the basic. Now this is our final concept diagram. Now, first of all, the viewing station is run off the normal power source, okay? So we've got the viewing device, the alert system, and the control mechanism all coming back to the user, which he will use, of course, to view and control and alert, or well, be alerted that there's an environment out there, what's going on anyway. And now the camera is all running off a solar charger system, which is then hooked up to a battery. Also, and now that battery supplies the camera and also the rotating device. And yeah, vice versa. It's still got the basic setup of the camera with like the infrared and the mechanics and the and in this one we've incorporated motion sensor as well. So this is going to be viewing the wildlife and environment. So yeah, and it all comes back to the user.
Okay, so this is the logic diagram of how our system operates. Normally we would work up some solid models in SolidWorks to show the actual design of our equipment, but we were actually advised that a logic diagram would more accurately explain our project. So the basic operation is explained in this section of the chart. So basically the camera images stream to the recorder, and the user views the system on their computer and selects which camera they want to view, and the recorder will stream the relevant image to the website. And while that default operation is going on, the system is also monitoring these three options here. So basically the system is always looking for a motion of the control stick, and if it detects one, then the camera will move in the direction that the control stick is being pushed. The system is also monitoring for low light, in which case if the system detects low light, then infrared LEDs on the camera will turn on to give a better illumination of the area. And if the motion sensor on the camera detects movement, then the recorder, the central recorder, will actually start recording the image, and once that movement stops, then it will stop recording and just return to a normal stream.
In this slide, we compared our targets to our final design. Most of it was the same, although the response was better with 0.4 of a second compared to 1. The clarity was the same, the control was the same, reliability the same. The expense per camera, it really impressed us, $390 difference. The night mode, 30 meters improvement. The software, it could run up to 20 cameras simultaneously, which is pretty impressive. Our functionality, we had inbuilt motion sensors which could turn the camera on and off. The durability, it adheres to IP66, which is worldwide standards.
So what is IP66 anyway? Basically, it's an international standard for durability. Different products can have different IP ratings. The IP stands for ingress protection. The first digit indicates the level of protection for personnel and equipment. A rating of 6 means that any object larger than 1 square millimeter cannot enter the enclosure, and also that the enclosure is completely sealed against dust. The second digit indicates the level of protection against water. A rating of 6 means the enclosure can withstand a 100 litre per minute jet of water from a distance of 3 meters on all sides for up to 3 minutes. Anyway, let's get back and finish this presentation.
And our total cost ended up around $600 less.
This has been a presentation by Blue Teeth. Hoorah!